Come on, guys. Work on the my homemade C3 tool, which is, it used to be a 4-port charger, and I got it off of eBay knowing it was broke with the plans to do this, but I made it so that you can plug this into your device and you about to put the smaller, was a lithium battery that was junk, the smaller lithium batteries, or not lithium, lithium batteries in here, and you could use them without overheating them on stuff and get longer runtime because you got 4 batteries plugged in. I made it so that you put it on your back and use the weed eater for a really long time because you got 4 batteries. But I want to do some upgrading to it. This cabling isn't heavy enough, and pretty much I'm going to run just duplicate cabling alongside of this. And also, I didn't have a special Torx bit that took these screws out, so I ended up breaking this apart to fit, to build this tool. Now I have the safety bit to go get it apart, but tape didn't hold it together and that, so I'm gonna replace that, this end with one that I could take apart. I have an old NiCad battery, and I took it apart, and I needed somewhere to be able to run the new wires in and be able to, splice them all together. So I took a couple of the batteries out, and you can see with this design that it uses the integrity of the battery is the fact that all the batteries are soldered together. And another issue I'm having with it is the top terminal for positive, it actually connects to the top of the last battery in the series, and I can't get a wire into it and be able to put this back together. I had a thought with the situation right here is that I could pack like a Walmart bag down in here, take this place up so that it stays together. But I just don't know how I'm going to get this wire here is for a thermal overload shutdown. It's not very heavy, so I got out one of my lithium batteries. This battery here gives me trouble once in a while because the circuit board on the battery allows the lithium batteries to be ran down too far, and when I put it on a charger, it sometimes is just a headache to try to take charge again because the batteries are so low discharged. And the batteries are all good, and this has, there's not a battery up in here. It actually has some nice structural integrity without relying on the batteries. So I think I'm gonna go with using this one, and I want the batteries out of here just in case, later on down the road I have one of these batteries go bad in one of my other packs, that I can potentially solder in one of these. You can figure out which one's bad by just taking it apart, and you can put a voltmeter on each end of each battery and you can test the voltage of each one. So right now they're all like 3.7 or something like that. This is the only battery I have that has one of these gauges, and I want to try to see if I can get this gauge to stay working. You're able to have a battery plugged into here and actually be able to tell the state of your charge still by pushing this, even though there won't be any batteries in here. And how I think I'm going to go about it is that once these batteries are out, you can see right here's the positive and negative wires that goes down to the board to go out. What I'm going to do is try to solder my output wires to the other side of this circuit board, so that the circuit board is powered whenever you have a battery in here, because this thing obviously runs on a reduced amount of voltage, and is powered by the board. So this board has to have power for this light to work. But then you could tell that it measures, this little board here itself measures the level of what you have, because the wires all run up inside of here. So 2 of them goes to the LED on the side, and looks like 2 of them actually go to measure the current on the terminals. And you guys will see what I did inside of here. Pretty much there's a circuit board in here because it was a charging unit, and I cut all the traces to each terminal, but used the soldered on terminals on the board to make a contact, and I soldered wires to the back of those contacts. And then there's also a diode on each one of these, so that power can't be transferred from one battery to the other, and you also can't charge the unit. Power can only come out, it can't go in, and you'll be able to see what's inside of there. Alright, so I got the lithium batteries out. Yeah, I think I'm just going to leave them, like, see how they're hooked together? I'm going to leave them hooked together just in case, whatever situation I got to put them in. You know, one end being hooked to the other might be in my best interest. Got to looking at this board, and my theories on soldering with these wires connect wouldn't be a good idea to make this light work. So what I'm going to do is, here's positive. This big piece right here, solder blob, is positive, and this is negative. And I'm just going to run my wires and connect to those points. And then that's where the batteries introduced, you know, in their series, introduce power to this board. And that should make my light work. And then to fill the space where the batteries was, I'll just shove this down into the, you know, the new top, and then I'll just fill the bottom with Walmart bags. It's not conductible, and it'll fill the space and keep stuff from rattling around. Alright, so I got the wires soldered to the bottom from the pack. It's wired in where the batteries, you know, after, you know, beginning and end of series. And it's not going to work. Basically, when I got to looking at this, it takes a battery reference from each pair or each battery individually. It looks like pairs, like 2 batteries together, 2 batteries together, 2 batteries together. It takes a reference voltage from each one of those, and this doesn't have a reference because there's no batteries in the center of it. And it turns on for a split second, and then it realizes there's something wrong with it. Like, I've held in this button down here on the end, and it'll light up green, and then it shuts back off because this thing's smart enough to know that there's no batteries in the center. So there's no way this is going to work. I can just solder these connections directly to the outputs of this, and it'll work, but I won't be able to get the little gauge to work. Pretty much, lithium batteries has been around for, I'll say, 30-ish years, and they wasn't introduced to the public for a while because of the dangers of them. They can explode if they're overcharged. Shorted out, they can explode. And so it requires the use of electronics like this to monitor every little bit of use that what you're doing with them, and so that they don't get overcharged, they don't ever get over discharged, and the safety aspects of it. So there's nothing I can do with it other than, you know, whenever you have the lithium batteries plugged into this, part of the reason that I put diodes in between on each terminal of these is so that there's not an issue with, you know, taking current from this battery and putting it in another, because of I thought about the lithium stuff, but I was hoping I'd be able to get this to work, you know, be able to see what kind of, you know, voltage levels. All this is just it checks the voltage of the battery and gives you a light, you know, different colors of light, you know, based on what voltages you have. But another thing I got to thinking about this is, even if it did work, even though I'm doubling up the cabling that's going to this, there's still going to be a certain amount of voltage drop. And this thing here, just say it did work, it's going to shut down prematurely because the batteries ain't right there. You know, no matter what I do, I could have 4 gauge cabling running into this pack and I'm still going to have a certain amount of voltage drop. You know, so this just isn't going to work. Most of the tools that you use on here is just a, you know, just a motor, and say I end up having a 1 volt of voltage drop to this motor, it's still going to perform, and pretty much probably maybe certain things like the impact where you're running down volts, that might have an effect on it. You know, with say a 1 volt voltage drop, you know, you might have an effect with how much you can, you know, have power you have as far as loosening or tightening something. But pretty much if I'm going to use the impact, I'm going to use the 3 or 4 amp hour battery anyways. But you know, so this is just ideally for saws and weed eating. But alright, so I'm going to resolder this up so that it's direct connection to these terminals. Alright, so I drilled holes in the bottom of the thing to wire up, solder the input from the battery into the bottom here to the wires going to the terminals. Now I have figured out that this right here is a standalone device. It works all on its own, and it runs on the line voltage, the 19.2. So I got wires held into there. I can't hold the wires on and, you know, push the button at the same time to show you guys, but I'm going to solder these up and tape everything up, and I'll show you that it works. But this light lit up green, and when I was connecting it to the output of the battery, so this will still work. Alright, real quick here before I throw it all together, the light works. Alright, so the inside of this device, the inverter was in the front of here, or power converter. I took that clear out of here, just cut it off the board. And then you can see here, like I said, you gotta like cut off and grind connections to these terminals, so that way you're not feeding power into the old equipment. And then you can see here I made runs from one point to another with these, like from here to here. And then I actually utilized the diodes that was in the machine. You see the diodes. Right there's one of the diodes. There's diodes already in it. So that makes it so that basically these runs right here, I had to reverse the polarity of the diode. So that's why these are in here. And I just got to figure out I could reverse the polarity of the diode without actually removing the diode. So that way, yeah. Because what it was is that it was designed so that if you had a battery charging and then you unplug the charger, the battery isn't going to discharge into the device. That's why the diodes was in it. And I figured if those diodes was heavy enough to do the job for that, then they could also be used to discharge and not, you know. But all I gotta do is run my secondary wire in and connect to the same place this one is, and put it back together. Alright, got it all back together. Here is the end with the cord, and you see here it doesn't work whenever you got a battery, just to show that it is working. And then I got a fully charged battery. And then I can put up to 4 batteries in this pack. What this is handy for is, like, say you got the hedge trimmer or the weed eater or something, and like me, I got 8 of these little batteries, and there is only these things really ain't useful for every tool. But with this pack, I'll be able to I'll get more use out of these littler batteries. And like I said, you can I mean, you can even put these big batteries in this thing and go with your hedge trimmer and go hedge trimming all day long, you know, so, you know, it makes it handy. But, you can see here, we'll put the drill on it. Oh, got it backwards. You know. But, I'll catch you guys later.